So today we are working on 9B, which is relations and functions. Our content objective is students will be able to determine whether a given relationship defines a function. Our language objective is students will be able to verbally justify why a relationship is or is not a function. Why am I learning this? Well, it's important for real-world problems like showing how finishing positions and scores in a track meet. So first, what is a relation? Relation is basically any set of ordered pairs. Okay, what is a function? Well, a function is a relation that assigns to each x value exactly one value. So in other words, for every x value, there is one unique y value. So here, there are ways to represent functions and relations. We can use mapping. So here, 1 is to 6 as 1 is to 7, and 2 to 7. So here, the ordered pairs would be 1, 6, 1, 7, and 2, 7. In another example, same thing. The ordered pairs would be 1, 6, 2, 6. So now let's talk about which one's a function. Here, notice for one x value of 1, the y value was 6. But again, for another x value of 1, y in this case was 7. So this one, there isn't a unique value for each x value. So we would say this is not a function, okay? Because 1 can give you a 6 as well as a 1 giving you a 7. Whenever you plug in 1, you should only get one answer. What about this? Is this a function? The answer is yes, because for each x value, there was one unique y value. If x was 1, y was 6. If x was 2, y was 6. That's okay. So that is a function. So now what are ordered pairs? So I'm going to start introducing some other words. So here, input values are basically your x values. So you know what x values are. Now we're going to introduce the word of inputs. So basically, they're the first numbers in the ordered pairs. Now, outputs are the y values. So those are going to be the second numbers in an ordered pair. Real quick, another word for input would be your domain. Okay, that's going to be another vocabulary word that we're going to be using. So you can, domain, x values, input values, those are all the same things. Another word for output or y values is going to be the range. So now, if they ask me to state the input, they could also ask me to state the domain. They mean the same thing. I'm going to go ahead and list the x values, or in other words, the first numbers. So what are the x values? The first numbers, which is 3, 4, -3, 0, and -4. So notice when I write them, I use these special brackets to represent the list. So I wrote 3, 4, -3, 0, and -4. Okay, well, there you have it. All the numbers in red. What if they asked me for instead, what is the output? So real quick, another word for output would be range. Okay, so just keep that in mind. They could say, what is the output or what is the range? So here, just keep that in mind. They can ask you either of these questions and it means the same thing. So my range is the y values, or in other words, the second number in the ordered pair. So that's going to be -2, 1, -4, 2, and 0. So again, I'm going to go ahead and use these special brackets to indicate the list of numbers. So -2, 1, -4, 2, and 0. So just a friendly reminder, input, x values, domains, they all mean the same thing. Outputs, y values, and range, they all mean the same thing. Okay, so is this a function? Well, for each x value, was there a unique y value? Yes, there was. So this one would be a function. Okay, so what about this? Y equals 2x. If I were to create an x and y chart, looks like a T-chart, you would go ahead and pick values for x and then figure out values for y, which we've done a while now for graphing. So here, this is an x and y chart. Well, what is the mapping going to look like? Well, so notice input, or AKA your domain, and your output. So here, input is all the x values. So you're going to list all these numbers into your input. And what is your output? Output are all the possible values you would have gotten out, which is your y values. So notice -4, -2, 0, 2, and 4. So here it just means when you plug in a -2, you got a -4. When you plug in -1, you get -2. When you plug in a 0, you get a 0, and so forth. So here, if I were to ask you, is this a function, you would say yes. Why? Because for each x value, there was an unique y value. So for each input, there was a unique output. And real quick, I just want to show you what this graph would look like. Okay, so keep an eye out for what do the graphs look like when they are a function, and what do the graphs look like when they're not a function. Okay, so what about this? So here, y equals the square root of x. So I'm going to go ahead and create a t-chart and get some values. I'm going to also map it out with inputs and an output. So input is basically all the x values, so I'm going to go ahead and put these numbers in. And output would be all the y values, so I would go ahead and put that in here. So here, I can map it for you, -2 to 2. So here, the order pair is -2, 2, so that's going to go from -2 to 2. -1 to 1. -1 to 1. 0 to 0. Okay, 1 to 1. 2 to 2. As crazy as this may look, the question's still going to be, is it a function, yes or no? The answer is yes. Why? Because every input had a unique output. Okay? Every input had a unique output, so it is a function. Draw some meter lines there. What about this one? Here, I'm actually going to go backwards. It's going to be a little bit easier to plug in y values to figure out your x value. So here, I'm going to put some values in for y. So here, what's the absolute value of -2? X would be 2. What's the absolute value of -1? X would be 1. What's the absolute value of 0? X would be 0. What's the absolute value of 1? X would be 1, etc. So here, again, I'm going to do a quick mapping of input and output. Notice, again, if you wanted to, you could refer to this as the domain and this as the range. So here, you're going to go ahead and put the different input values, which is 0, 1, and 2. Okay, those are the different values you could have put. And what are the different values for y? -2, -1, 0, 1, 2. So you put that for your output. So now I'm just going to go ahead and map it out from 2 to -2. I'm going to go from 2 to -2. 1 to -1. 1 to -1. 0 to 0. Okay? 1 to 1. Oh, look. I'm using the same x value, but now it's having a different output. That doesn't look so good. Let's see, 2 to 2. So here, another x value, but this time it's going to a different output, different y. So here it's not looking good because for each input of x, there was a different output for y in different occasions. So this is not a function. Okay? So notice if you have more than one branch coming off of an input, that means the output is not unique, it's being shared. So this is not a function. So real quick, these are the graphs of the equation. So notice this represents a function, but this does not represent a function. Okay, so what have we talked about so far? We've talked about input, we've talked about output, we've talked about how can we tell if something's a function. We know something's a function if for each input value, aka x, has a unique output value, which we can also refer to as y. Okay, so now there's a quicker way. If we're given a graph, we can use something called the vertical line test. This will tell us whether or not whether a graph is a function or not. So here, if a vertical line crosses a graph of an equation only once, it is a function. So guess what? If it crosses more than once, it is not a function. So let's look at an example here. For this example, if you were to draw a vertical line anywhere on this orange line, would it ever cross more than once? Let me show you. If I were to draw multiple vertical lines, it only crosses once, only crosses once, only crosses once, only crosses once. Okay, it crossed once here, 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 and here. So in this case, I would consider this a function. Okay, why? Because it only crosses the vertical line once. So this is a function. Now, what about the next one? Well, if you try your vertical line test, if you draw a vertical line, this one you'll see that it's possible to touch more than once. So this is not a function because it's touching more than once. So therefore, it's not a function. Okay, so here let's take a look at some graphs. If you were to scan over a vertical line, would it ever touch more than once? No. So this is a function. Okay? Here's just an example of what the equation might be, y equals 1/2 x plus 2. What about this line? If I scan a vertical line across this graph, will it ever touch more than once? No. So this one is also a function. What about, and real quick, a possible equation might be y equals 4 for this graph. What about this one? Here, if I scan over a vertical line, notice right there, it's touching more than once. In fact, it's touching infinitely many times. So it's touching here, 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 so many different places. So this is not a function. It fails the vertical line test. Okay? Quick example of an equation might be y equals 5. What about this one? Okay, scanning a vertical line. Notice it only touches once as it passes through, so this one's definitely a function. Okay, here's a quick example of an equation of what it might be that derived this graph. Now here, is this a function? The answer is no. If you draw a vertical line, notice it touches twice, once here and once here. So this is not a function. Why? Because it doesn't pass the vertical line test. It touches more than once. Okay, here's a quick example of an equation that might represent this graph. For this one, is this a function? The answer is yes. No matter how many vertical lines you draw, it will only touch this graph once, so it's a function. Okay, this one's called a piecewise function, okay, which you will learn later as you get older and you advance on to higher math courses. This one, is this a function? The answer is no. It does not pass the vertical line test. It touches more than once. Okay, so this is not a function. Here's a quick example of an equation that might be used to represent this graph. And last but not least, is this a function? The answer is no, because if you draw a vertical line, maybe one like this, you would find that it touches more than once. So it is not a function. Okay, so using a vertical line test definitely makes it a lot quicker for us to assess whether or not an equation or a graph, well in this case, a graph is a function or not. So it's definitely useful. Okay, so now we're given some mapping and some tables and as well as a graph, and we're supposed to determine whether or not it is a function. Okay. So for number 1, is it a function, yes or no? The answer is yes, because for each input there's one unique output. For each input there's exactly one output, which is great, okay? So number 1 is a function. Well, what about number 2? Number 2 is not a function, because notice here -3 is going to give you a -1 one time, but another time a -3 is going to give you a 0. And then in another case, a -3 is going to give you a 1. This is not a function, okay? For each input value, there should be exactly one output. In this case, you have -3 equaling -1, equaling 0, 1, and 2. So this is not a function. What about number 3? Is it a function? The answer is no. Why? Because it doesn't pass the vertical line test. In fact, I can draw one real quick right now. Bam, this vertical line, it touches 3 times. So this is definitely not a function. Remember, in order for it to be a function, when you draw a vertical line, it can only touch once. So what about number 4? Is this a function? The answer is no, because here, input of -2 would give you a 3, but it would also give you a 4. So that is not a function. Okay, so let's take a look at this graph. Is this a function? The answer is no, because if you draw a vertical line, you'll see that it touches twice. So it's not a function. Okay? Well, what about this one here, number 6? Is this a function? You may not have seen this before, but these open circles represent basically holes in the graph. So what do you think? Is it a function or is it not? If you said it is not a function, you are correct. Because here, if I were to draw a vertical line, okay, it doesn't touch more than once because these open holes represent a hole. So they're not included. So therefore, this one would be a function. Okay, so now, you've heard about the vertical line test. You're probably wondering, well, is there a horizontal line test then? The answer is yes. Okay, it's used to test whether or not the inverse of a function is a function. But you will discuss that in future math courses, and we're not going to discuss that as 8th graders here. So just understand that there is one. So quick summary, we've talked about ordered pairs. Each input has to have only one output. Okay, and then when we're looking at graphs, the vertical line can only touch once. If it touches more than once, it is not a function. So that is going to conclude our lesson for today. Thank you so much for tuning in. And like always, until next time, bye.